Hey guys, and welcome to Functional Print Friday, and welcome back to my barn. So I'm getting close to doing the actual solar panel install up on the roof for this EcoFlow Delta Pro 3, and there's some stuff I want to take care of before we do that, just some little things to kind of cross off the list, and I think I actually showed you this one before. So everything in this pile of stuff is what makes up the network connectivity up here in the barn, and this all runs off 12 volts. It's actually plugged into the 12 volt output on the side of the EcoFlow Delta Pro 3. I only turn the 240 volt output on this guy when I'm actually up here in the barn, because the inverter, whether you're actually drawing power or not, draws constant power from the batteries, and the solar more than makes up for it, but it's just not very efficient to leave that on when you don't need it. The 12 volt output on this guy is a separate switched output and is much higher efficiency for low wattage loads, and everything over here is a low wattage load. So that 12 volts comes into these two Wago connectors. So we basically have, like, I guess, a positive and a negative rail, you could say. And that feeds this little 12 volt buck converter that gives us 5 volts out for the USB-C in on the wireless router, so that I have wireless connectivity up here. There is a 12 volt PoE switch. This actually does not power the wireless repeater that we put in. The wireless repeater is powered directly by a pair of unused connectors on that Cat5e line that run right to our two, I guess you could say, sides of this 12 volt rail. So the camera itself is powered directly off 12 volts. The other connectors here, one is the little wireless access point, and then I have two security cameras up here that are PoE. So everything kind of in this pile here needs to be here, but it doesn't need to be here. So I think we have more than enough room up here on this big sheet of plywood for all of this stuff. However, I'd kind of like this to be somewhat modular. All this stuff does go together. And I've got to put a panel over here for the high voltage DC in that's going to come out of those panels once I get the solar panels up on the roof. So I think what I'd like to do is actually make like a mounting plate for all this that provides maybe something to hold the Wago connectors, some kind of predetermined points to screw all this equipment down. I don't think any of this stuff has mounting hardware. Yeah, none of this stuff is designed to be wall mounted, but we'll figure that out. And maybe we could even do some wire routing for the Cat5 coming in as well. That's the other reason I haven't trimmed these. There's way more cable here than I need because I just wasn't sure where the stuff was eventually going to really land. And, you know, it's easy to cut off. It's hard to put it back on. And this probably goes without saying, but the reason it's all here in this pile is because that's exactly how I left it after I hooked it all up to test it, and it worked, and then I promptly moved on to something else. All right, I'm going to get everything unplugged. Let's take it down to the shop, get it on the workbench so we can kind of get the dimensions of everything, and figure out how to design this. So none of this stuff is particularly big, but I think we're probably going to eat up, I'm guessing, all of the real estate of the Bambu Lab H2D to fit all this on one mounting board, because I want everything to mount separately and it be obvious how the wires are routed, so future me understands and remembers how I did this. I'd like to even mount the Wago connectors in some fashion. I don't know how we're going to do that, because these things are really designed to be as compact as possible. There's really there's no screw holes, there's nothing on here to facilitate mounting. But I noticed, at least this front section up here, we can obstruct that. So maybe we can just design something that sort of just pressure fit slides into. And I wouldn't mind designing some accommodations for assisting with the routing of the wiring too. What you don't see here on the bench is all those network cables. Remember, we have one coming from the router to the PoE switch, and then there is two security cameras and the wireless bridge plugged into here as well. So all those wires have to come join this equipment on that board as well. So, all right, I'm going to get some dimensions of everything here, and I'm going to get into CAD, and I'm just going to start seeing how I can fit things together within sort of the space constraint of the bed of the H2D, and I'll bring you guys back. And welcome back. So first thing I did is measure all the components and draw them here in CAD. And it's tempting to skip this step, but I think it's worth doing, especially in operations like this, where I think you really gain a lot in being able to move them around in three-dimensional space in your CAD software and then design around them. I also took the time to mark everything here in orange that is obstructed. So for example, the bottom of the router, this is where the ports are. This is where the ports are on the side of the PoE switch. This is the terminal block on the top for the positive and negative power. Our Wago terminals, this area up here we can cover, and a tiny little sliver here on the side. I think that's only about 1 millimeter wide, but that will help, and you'll see soon enough here when I unhide the board that these are going to mount on, how I'm going to hold these guys. And our buck converter just positioned above this to keep it out of the way, because we're going to have 12 volt in, and then we also have that USB out. So just kind of trying to leave some space to get down to the USB in port on the router. So if I unhide the board and the mounting covers here, you can see I kind of just designed the board around those components and imagining where the wires are going to flow between these devices. So starting up at the top, buck converter, this one is easy. It's got mounting ears right on it, so all I needed to do is just position some holes in the right place. And you can see the obstructions here. This is the power out, this is the power in. And I actually put a hole right through this block down here that the Wago connectors are going to slide into. So I should be able to have the input leads for that buck converter come right through that hole and then onto the positive side and the negative side. I want to print this in PETG. It gets pretty hot in the barn. I'm worried if we do this in PLA, it might warp over time or at least creep, which I don't want it to do. I just checked. I do have red and black PETG in addition to the dark gray color. So we'll do this as a 3-color print. I don't see any reason why not to. It gives us the opportunity to clearly show which one of the Wagos is the positive rail, which one's the negative, and also to be able to see the terminals up here on the top of this PoE switch, which is positive and which is negative. This little LinoVision switch is pretty sweet. I'll put a link to this down in the description as well. Not sponsored or anything. I bought this, but it's actually got 2 12-volt inputs, and you can connect them both at the same time. Like, they're not connected to each other. It's got some sort of a little internal switch. So you can have 2 power sources connected to this. So if your main source goes down, it'll switch over to a secondary source. So it's really nice, like if you're switching power sources, or if you want to have like a backup source that feeds this as well, maybe even a battery, you can do that. It's a pretty cool little device. The smart router, this one is a little bit trickier because it's got feet on the bottom, and I think they stand it off whatever you set it on so that heat can travel through this guy. So I left that open, and I ended up just designing sort of these 4 little, I guess, holders that kind of come up here on the side to try and minimize the amount of area that we're covering here for air ventilation. This guy has locked up on me a couple times just sitting up in the barn in the pile that it's in now. It did it when I had something covering over top of it, so I think it was just overheating. So I do want to make sure that the maximum amount of space on this guy is uncovered for air circulation. These mount slightly differently. The smart router, you can see I got a little cute here on trying to leave this uncovered. That's actually lit in there, so I figured that was kind of worth doing. And this just mounts down to 2 points here. This doesn't have to be super snug in there because it's mostly retained by these 4 holders that come up out of the base. This guy is a little bit trickier just because of the shape of the device and this terminal up here. So this one I designed to have 2 little sort of feet that come into, I guess, you know, call, I don't know, the front of a shoe that they slide into. And then there's a single screw hole down here in the bottom. So I should be able to put this bracket over the device and then slide the whole thing up into these 2 holders and put the single screw in here to retain it. Also got a little cute here. Wanted to try this. This, as you can probably guess, is to hold that incoming wire that ultimately ends in a barrel plug on the other end to go into the EcoFlow box. Did I need to do this? No. I mean, we probably could have just put some tie downs along here, but I thought, let's try this. I've always wanted to try sort of a retaining valley for a wire like this. The other things I tried here are some loops for the Cat 5e cables to come in, and then also just to divide those out as they go into the ports. That should be easy. I don't think we'll need supports for those either. And then these things here, my thought is zip ties. I basically sunk like half of a sphere into the face of the board and then put like a bridge at the top, thinking that I can feed a zip tie in one side and it should follow the curvature of that, pop back out the other side, and allow me to tie up the wires on here to neaten things up. So outside of that, we have the mounting holes in the 4 corners with a little bit of a bevel on them. We'll just use like drywall screws or something for that. And this is pretty much the full build volume, at least the full build volume footprint on the H2D, including using the area that is restricted to just one nozzle, which is fine because the whole plate here is going to be PETG of one color, and these colored sections will fall outside of that area that has the second color nozzle restriction. So, all right, I'm gonna get this sliced up. We'll get this printing out, and I'll bring you guys back. So I think the best way to describe how I feel right now is disappointment and frustration. The whole reason I was excited about getting the Bambu Lab H2D is because I didn't want to do prints anymore that were big like this on the Neptune 4 Max. Every single time I use that Neptune 4 Max, I'd have to wait 2 hours for the bed to warm up and stabilize, so the bed didn't turn into a banana during the print, and you'd end up with this same issue of horrible over extrusion to the point where the print is failing in the corners. And even after that warm up, the bed would still move around. The print probably would look better than this, but it would still move around. And of course I can't do multicolor on that machine. Is multicolor necessary for this? No, but I think it's a good fit for it. I think this will easily help me identify what, where the positive and negative connections are when I go to service this in the future. And here we are with a machine that I think is honestly the sweet spot for a Core XY machine. I say that because if you go any bigger than this, and I think all of us would like bigger, right? I think there's no such thing as a printer that's too small until you go to move it around. I will tell you that this machine, the Bambu Lab H2D, is probably about the largest printer that it makes practical sense to sell in a non-industrial environment. I'm sure someone's going to make one bigger. I know. But I'm telling you, having picked that thing up and moved it around, I can do it by myself. It really takes 2 people to safely move it. And if you went any bigger, you'd probably be looking at a machine that might take 3 people to move it around. It's a big printer. And it needs to be big to give you a build volume that's this big. And I really thought that Bambu Lab would have gotten this right and designed this machine that we did not have lifting on the corners. Now you saw in that video, the print did not detach from the print bed, and you can see that from the texture here on the bottom as well. There is no difference in the texture on the corners. This print did not lift from the print bed. The print bed itself lifted from the magnetic base. So it seems like they have enough stiffness in that base, but if the bed's going to lift from the base, what is the point? Like this is, and that comes to my disappointment here. I really, really wanted to like this machine, but I think we're actually going to have to adjust this design to accommodate for that bed lifting in the corners. So I'm going to go back to CAD, adjust this. I'll bring you guys back. All right, so here is the updated design, and I've got it next to the original design. In addition to cutting off the corners so we don't come all the way to the edge of the build plate, I also shrunk it down a little bit. I just slid everything a little bit closer together. It's nice to have all this real estate here, but we really don't need it. I think we'll have plenty of space with this. And I also put this guy at an angle to save some space up here. That was a little bit tough to slide over and still leave myself enough room to have like a wire loop over here. So by turning it this way, I think that works out really well because that positions still these wires here to drop through this hole in the Wago terminal holding block. And we should still have enough room over here to have like a loop of wire for the USB port that's going to feed the smart router. And I adjusted the position of our zip tie little loops here as well. And I also tightened this guy up a little bit. That failed print did complete enough for me to try the wire in there, and I wasn't too happy with how it fit, so I tweaked the design a bit. I made it narrower, but then I also have these sort of little cutouts on the side so that the wire kind of has to bend a little bit to push into place, but then can straighten out underneath and should be restrained in there a little bit better. Outside of that, I didn't really change anything else here, so let's slice this one up and let's hope that this resolves our issue with the corners. I'm honestly kind of lost for words. I think I actually need to just sleep on it and think about this. Actually, let me grab the other one. So you can see how much smaller this is. It's actually, I think I took off probably about 20 millimeters in one direction. It's the same in this direction. And then of course we relieved all the corners. So we're no longer on the part of the bed that lifted. And I did actually notice some lifting. I think it was this edge here. The bed was kind of lifted up in a little bit of a C shape. It was actually still touching here on what would be these corners, but it was lifted up in like a C shape in the middle. I think the PETG is shrinking and distorting during the print. I'm going to sleep on it. I'm going to think about this tonight. And I'm going to come back at this tomorrow with a fresh mind, because I mean this is terrible quality. I'm kind of without words. All right, I spent a lot of time last night thinking about what could be causing the problem on this machine. I don't think it's a hardware problem. I could be wrong. I really hope I'm not, because everything about this machine prior to this frustration I'm experiencing with this specific print has done nothing but impress me. The engineering in this machine is truly next level. Everything about this machine is exactly what you would want to see and what you would expect in a next generation machine from Bamboo. I think this is a software problem. I think the only reason I don't experience this problem with my X1 Carbon and my P1S is because I ignore Bamboo Labs' advice. And by that I mean, I never take this lid off. And almost all I print is PLA. You guys know that. I mean, the first question I ask myself when I design something is, will PLA be sufficient for this? And honestly, the answer most of the time is yes. That's why we make so much stuff out of PLA on this channel, because it's actually a lot more versatile than I think people give it credit for. And I never bother taking the top off my printers when I print either my P1S or my X1C. I never open the door, and I've never had a problem. But I'm also down here in my basement. So the temperature down here in my basement is pretty consistent year-round. It's usually about 72 degrees, and that comes down to the fact that we've got concrete walls, we're underground, a concrete floor, and sources of heat as well. So I have a whole server rack of equipment here, and there's about half a dozen 3D printers that are probably going about half the time. The one time of the year that the temperature is not super consistent down here is actually right now, because there's days where I have to put the air conditioning on and then days that I have to put the heat back on. So I don't have the vents in the basement here switched over to summer yet. I normally close them all because we don't need any air conditioning down here. But right now, this time of year, they're open. So if you haven't already figured it out on your own yet, here's what I think is going on. One of the differences between the Bamboo Lab H2D and their previous generations of machines is you don't have to take the top off and open the door to have ventilation in the chamber. It actually automatically ventilates itself by opening up a port up here on the top and opening up fins on the back. Here, I can actually do it manually. So at the start of the print, that guy opens up. There's a little servo in there that opens it up. And we can hear the fan. If we walk around back, you can see there's fins up here that open up. It's actually not just the air that's pushing these open. These actually are opened up by a servo as well. And it's blowing quite a bit of air. It does not run this loud or move this much air when it's printing. It's probably running at 100% because we turned it on manually. Let me actually walk back around and turn it off. Yeah, that was running at 100%. I think it runs at a closer to like 20 or 30% during the print. But here's what I think is happening. I think that when the AC cycles on down here in my basement, the ambient temperature actually drops by probably about 4 or 5 degrees initially when it turns on. I think it's drawing that cool air in, and I think it's just warping the print. And I think that's why we're seeing that weird pattern on the print. I don't think it was ever a problem with the corners, because we saw it exhibited even when we shrunk that print to substantially smaller and got it away from the corners. And if you think about it, I know the print's not in here now, I should have grabbed it so you could see, but when I thought about how the print was oriented in here, and I thought about the air coming in at the front, sort of going down and then getting sucked out in the corner back over there, it makes perfect sense. Now what's frustrating is I've already looked in the slicer and I don't see an option to turn that off. Like if you print PLA or PETG, it just turns it on automatically. I did notice I can turn it off. I did run just a quick test G-code and it started the fan, but I was able to come in here into this control panel and turn it off. I was able to come in and just flip that little slider here the same as I did while the machine is idle. So that's what I'm going to do. I'm going to start the print again, and I'm going to manually turn off the chamber cooling, and we're going to see if that makes a difference. I am really, really hoping that this works, because if it does, that means this is just a software problem. It's not a problem with the hardware. It's something that Bamboo can correct, or at least give you the option. Because here's the thing. If we were in a room that had an ambient temperature of, say, I don't know, like 95 degrees, like an unair-conditioned space in the hot summer, I think if you didn't have the chamber cooling on, you'd have a very different problem. You'd probably have constant clogs from the filament getting too hot before it actually got down to the hot end. I think you'd have extrusion issues. Thing is, I can't imagine I'm the only one in a space where the ambient temperature is, you know, kind of in that 70, 72 degrees Fahrenheit range, and then maybe it even drops a little bit when the air conditioning cycle's on. So yeah, let's test it. Let's see what happens. Well, would you look at that? This print is pretty much flawless. Top and bottom is gorgeous. I don't see any issues here at all. I didn't turn supports on. I figured we could just clean up the parts with the bridging here if we needed to. It actually looks like it bridged that perfect. The pockets for the Wago terminals, a little bit messy, but I think we'll get them cleaned up. And also, there wasn't room here on the build plate for a prime tower. Normally with multicolored printing, even on the H2D with 2 tool heads, you still leave the prime tower enabled so that it can build up the extrusion pressure when switching filaments. Again, there's no room, so I just turned it off, and even those look great. There's maybe a little bit of wispies and imperfections here, just a little bit, in the color patches that probably wouldn't be there if we had room for a prime tower, but I mean, honestly, it looks pretty darn good. So there is 0 differences in these 2 prints, except, well, obviously I canceled this one before it finished because, oh, I forgot to say, it wasn't just the appearance of this. The whole reason I discovered this problem, because normally with Bamboo Lab printers, I don't even check the print while it's going. I just wait for the alert in the app telling me that it's done. I got an alert from the app that the extruder was clogged because the sensor in the extruder, when it got to these parts that were wildly over extruded because it was lifting up, it was sensing that the pressure was super high in the nozzle and it stopped the print. So this one obviously was canceled early, but outside of that, these 2 prints are identical. It's the same G-code that generated each one of these, and you can see how wildly different they are. The only difference is after the print started, I manually turned off chamber cooling in the menu for this one. So I am going to reach out to Bamboo Lab and share my findings here with these 2 prints. I'll probably actually just send them this video so they can see the results for themselves. And I did a brief look online. I couldn't find anyone else complaining about this exact same issue. Now, again, it was a fairly brief look. I can't imagine I'm the first person to encounter this, but this is a fairly new machine. There's not a whole lot of these out there. And I didn't uncover this until I printed PETG. I didn't have any problems with PLA really at all. Although I guess we didn't print anything sort of this shape in PLA either. I did find plenty of people complaining about what they were thinking was inconsistent temperature of the heat bed. And I think what's misleading on that machine, or what's misleading people on that machine, is there's 2 different heaters in the bed. There's one that brings the bed up to temperature very quickly because it's such a large bed and has a high thermal mass. And then there's a smaller heater that actually maintains the temperature throughout the print. And I'm wondering if inconsistencies in temperature in the bed are not down to the thermal design of the bed, but people encountering that same issue of cool air coming in the vent in the top and messing with the temperature of the bed if their ambient temperature is lower like mine. Like, I'm curious what conditions Bamboo Lab tested these machines in. All right, end rant. Let's get the other 3D printed pieces for this over here and see if they fit. So I didn't even show you these before. I was so busy fighting with the printer to get a good result for this piece. But this is the first set of prints that I did for each one of these, and both of them were close. Neither one of them fit the way that they should. This one, as you can see here, is just a little tight on the body of this. Probably could have pushed it and made it work, but I've got a revision of this one printing right now that's a little bit bigger. And the one for the router actually fit okay. I just didn't like the way that my cutout here around the text just didn't seem even. around that. I'm totally being nitpicky, but if I was reprinting the other one, may as well reprint this one as well. So as soon as those are done, I'll bring you guys back. All right, our updated prints are done, and these are also done in PETG HF. I printed these on the Bamboo Lab X1C just while I was fighting with H2D for that. So see if this fits better now. Oh yeah, fits nice. Let's see if my nitpicking paid off on this guy. Oh yeah, I definitely like the look of that over the first one. And this one actually fit just fine. It was literally just me adjusting that so that it better framed the Smart Router logo on there. This also needs to key into these pockets here. Let's see how we did for that. The left side's snug, the right's a little looser fit, but it does go all the way in. And it lines up on our hole for the screw. Guess we could actually try it in there, huh? Oh yeah, that actually, it's like the perfect size now. There's a little bit of pressure to hold this down, but it pinches it in there really nice. And you can see our terminals line up with our color coding, because this thing's going to be up on the wall. I'm not going to be able to see that text. It's actually the text that shows you the polarity of the terminals is on the back of this. We'll never see that. And our Smart Router, this should drop right into here. Yep. And you can see the feet are holding it off the bottom, so we still have airflow behind this guy. That's why I have this one attached like this. And see if these line up. Yeah, that looks good too. All right, you know, I guess there's really no reason to take this up to the barn and assemble everything up there. We could pretty much put this all together down here in the comfort of the shop and then just finish it off up there. I'm trying to think what we'll have. Yeah, we'll have to wire that one Cat 5 that has the 12-volt power that feeds on the spare pair of wires up to the wireless bridge. We won't be able to wire in. And obviously we'll have to route the Cat 5e cables that come into the switch when we get up there. But yeah, I think we can do everything else down here. So let me get the camera off to the side. Let's get this together. All right, so far I am really happy with how this is turning out. Definitely a significant improvement from where we started. The channel here for the incoming power worked out really nicely. I was able to slip the wire in there just fine and it's staying put. The Wago terminals slipped in here really nice. I think that was actually courtesy of that little bit of bridging material hanging down, just made those like the perfect snug fit. They were, I mean, I wouldn't change anything about that. So I have to remember that I have good geometry that works for mounting these Wago terminals for other projects. Color terminals made it, or the color coding made it really easy to see which terminals were which. The zip tie points pretty much all fell in the right spots. That one was perfect there. This one should be a little bit further down, and then I wouldn't need to use both these. This one I think I'd move over here, but I don't really need it. That one was to accommodate the set of power leads coming off of the unused Cat 5e pair for the wireless bridge. To come over to the Wago terminals. I don't need it for that. It ended up falling in the perfect spot for both sides of the little wire loop here for the USB-C, and that puts this guy in a nice spot here, the connector. So the one remaining one, that'll hold this down, as well as that one other wire that's going to come over here once we get the Cat 5e cables back in here. The zip tie holes here ended up working out really, really well. I kind of guessed on the dimensions of these, but if you just put a little bit of a bend in the end of the zip tie, and of course this is with my left hand, but you just push it down, it loops right around. and comes right up out of there. Like, that is super convenient. So if you have projects where you want to incorporate zip ties flush with the surface, that's a really good way to do it. And of course, the STLs for everything that I'm showing today will be available on my site, fpfdesigns.com. I can't imagine that you're going to want to use this thing as is, but hopefully watching this video, you got some inspiration for design ideas for other things that you're putting together like this. And if you want to download this, even just to steal the dimensions for, like, say, the zip tie holes, or this sort of channel here for the wire, or for the Wago terminals, feel free to do that. All right, well, I think we're about as far as we can get down here in the shop. I still do need a short Cat5e patch to come from the wireless router down to our PoE switch, but I think my Cat5e tools and the bag of wire is actually up in the barn, as well as the crimpers. So we'll do that up there, and we're going to need an impact driver and 4 screws to get this guy on the plywood. So let me get all that together, and I'll bring you back when I'm up in the barn. All right, I think that is maybe a slight improvement from where we started. Maybe just a tad bit more organized than the giant electrical octopus that we had down here at the start. So yeah, let me know down in the comments what you guys think. Overkill on this, or just the right amount of kill? I'm really happy with it, but I'm biased. I mean, it was my time, it's my barn, so I like how it looks, but yeah. And one of the things that's nice about having this design now, if I do need to change one of these components in the future, I can just open this back up and just modify this plate to accommodate for whatever piece of equipment I need to swap out on this, and I can just reprint it, reinstall the equipment, and I'm good to go. Well, guys, I'm really happy with the end result we got on that. We had a lot of frustration along the way. I'm really disappointed in these prints from the H2D, but again, it is a software problem, not a hardware problem. So there should be an easy fix by Bamboo. I think even if they keep the default the way it is, giving us a checkbox for whether we want chamber ventilation or not, I think would solve 90% of the problem. And realistically, that's not even in the firmware of the printer. My guess is the printer's just responding to special G-code that's telling it whether to run that chamber ventilation or not. So I think this is something that they could fix completely within the slicer itself, but I'll let you know what I hear back from them. Guys, as always, thanks for hanging out in the shop with me for this week's design and video. And if you've got any questions about this design, or if there's anything that you would have done differently, please feel free to let me know down in the comments below. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints, more of that engineering and functional side of 3D printing. So if you're into that, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.